Okay, today in chemistry, we're going to continue chapter 12, and we're going to talk about forces of attraction and then go on and talk about solids and liquids. Okay, so forces of attraction are important to determine the physical state of matter and then certain characteristics. So if the forces are really strong, then it's going to be a solid, and if they're not strong at all, if there's no attraction, it's going to be a gas, and liquids will lie somewhere in between. So before we start talking about forces, let's talk about intramolecular versus intermolecular. So intramolecular, okay, so there's a chart on page 411 of your book. These are forces that occur within. So when you talk about ionic bonding or covalent bonding, those are examples of, and metallic bonding, those are examples of intramolecular forces. Intermolecular forces, on the other hand, are the forces that occur between two molecules, okay? And they will include things like dispersion forces, which are also called London forces. Some people call them London dispersion forces. Some people call them LDFs. These are weak forces that result because of temporary shifts in the density of the electron in the electron cloud. So electrons are moving around, and there are going to be some electrons that are attracted to other regions, and that's going to be there's going to be a temporary attraction. So this results because two atoms or molecules come close together. Their electrons will repel each other, creating tiny regions of partial charges, resulting in temporary dipoles or temporary charges on these molecules. All molecules, so it doesn't matter what kind of molecule you're talking about. Remember, molecules are formed from two or more nonmetals, will have dispersion forces. Although if you're talking about noble gases and nonpolar, that is the only force of attraction. Although these are weak forces, dispersion forces become stronger as the size of the atom increases because you have more electrons. Okay. Next, you have dipole-dipole forces. These occur between polar molecules, so molecules that have partial charges all the time. Polar molecules have what we call permanent dipoles, so they're not temporary, they're permanent. So one portion is always positive and one portion is always negative. I don't think I spelled permanent right. P-E-R-M-A-N-E-N-T. And I messed that up royally. Okay. Some regions are partially positive and some regions are partially negative all the time. These regions of partial charges will attract the opposite charge on different molecules, and I think your book probably shows you a picture of that. And then finally, you have hydrogen bonds. Hydrogen bonds are a type of dipole-dipole force, so these are a special type of dipole-dipole attractions. These occur between a hydrogen on one molecule and either a fluorine, an oxygen, or a nitrogen on another, and you show them by a dotted line. So if you have water, so you have OH, oxygen is partial negative, hydrogen is partial positive. Remember, we talked about that when we did electronegativity in another chapter. And if you put another water molecule in the vicinity, this negative is going to be attracted to this positive, and you show that by a dotted line, and that is your hydrogen bond. So it occurs between two different water molecules. Okay, next up, liquids. Liquids, the particles are attracted to each other by intermolecular forces. And I think I'm just going to do this. It might be easier. The particles will vibrate and spin while moving, and liquids, just like gases, can flow. So the particles will spin and vibrate while moving. There's not as much space between particles due to stronger intermolecular forces. So therefore, they're going to be more dense and less compressible than gases. Most of the particles do not have enough kinetic energy to escape and go into the gaseous form. Now, you'll have some that do, and especially in a closed container, but most will not. Properties of liquids. So there's something called viscosity. So like you would say that honey moves slower than water. So you'd say honey has a higher viscosity than water. So viscosity is the resistance of a liquid to flow. The stronger the intermolecular forces, the more viscous the liquid is. So you would say that honey has stronger intermolecular forces than water does. Also, the larger the molecule, the more viscous. Temperature can affect viscosity because like if you cause these molecules to move faster, then they can break apart from those intermolecular forces and become more of a liquid form, or more liquidy, for lack of a better word. Okay, the next thing is surface tension. Surface tension is the energy needed to increase the surface area of a liquid by a given amount. And these are just definitions out of your book. And then when you talk about liquids, you can talk about something called cohesion and adhesion. Cohesion is the attraction between like molecules. So for instance, water to water. Adhesion is attraction between unlike molecules. So for instance, water to glass. It's like water on your windshield. And then with liquids, you can talk about evaporation versus vaporization. Evaporation occurs only at the surface, okay? So vaporization is the conversion of a liquid to a gas or vapor. When you talk about evaporation, that is occurring only at the surface of a non-boiling liquid. So if you have water sitting on your counter in a cup, 5 days later, it may all have evaporated. It has to have, those molecules that evaporate have to have enough kinetic energy to overcome the intermolecular forces that held them down. It is a cooling process, so whenever evaporation occurs from your skin, because the particles with the highest kinetic energy tend to escape first, leaving behind particles with lower kinetic energy, so the temperature decreases. If you have a closed system, so you have a jar with water sitting in it, some of the particles in the liquid vaporize. They'll collide with the walls of the container, producing vapor pressure, which is the force due to the gas above the liquid. As time passes, the number of particles entering the vapor increases. Eventually, some of these particles will return to the liquid and condense. Eventually, the rate of evaporation and the rate of condensation will equal, and we say the system is equilibrium. If you start seeing moisture on the sides of your jar, that indicates equilibrium has established. And then when you talk about liquids, you can also talk about boiling point. Boiling point is vaporization is occurring throughout the liquid. So it's the temperature at which vapor pressure of a liquid equals the external pressure. It takes place at specific temperatures and pressures, so there'll be a table for it. Atmospheric pressure will oppose the formation of bubbles in a liquid, so the atmosphere pushes on the liquid, reducing the likelihood of bubbles being formed. So bubbles form only when the vapor pressure inside the bubble is equal to atmospheric pressure. So once again, this is just stuff that came straight out of your notes, or straight out of your book. And then solids. Solids have the strongest intermolecular forces of the three, and these molecules are allowed to vibrate around fixed points, but they cannot flow. So your particles are tightly packed against one another in a highly organized pattern. So they tend to be very dense. So when you talk about solids, you talk about melting point and freezing point. So melting point is the temperature at which a solid turns into a liquid. It occurs when heating causes an increase in the kinetic energy of the molecules, which causes vibrations to become greater than the intermolecular forces holding them together. Ionic solids tend to have higher melting points than molecular solids because they tend to have stronger forces. Ionic bonds are stronger than covalent. And then freezing point is just simply the opposite. It's when the temperature at which a liquid turns into a solid. Okay, whenever you talk about solids, you can talk about a crystal structure, and the unit cell in your book in the solid section will show you some pictures of this. So a crystal lattice. So in a crystal, atoms, ions, and molecules are arranged in an orderly, repeating 3D pattern called a crystal lattice. All crystals will have regular shape, which is determined by the arrangements of the particle within them. There are different categories of crystalline solids. So for instance, molecular solids, think of water, sugar. So it's just a molecule. Covalent network solids have atoms bonded by covalent bonds in a continuous network extending throughout the material. So for instance, diamond. And then you have ionic solids, like would be an ionic compound, which is a metal and a non-metal, so table salt. And then you have metallic solids, which would be like copper and a sea of electrons around that copper. Allotropes are different molecular forms of an element in the same physical state. So, for instance, if carbon could be in a solid, liquid, or gas, those would all be allotropes of each other. For instance, so diamond, graphite, and buckyballs or buckmühl-finster are allotropes of carbon. And then amorphous solids, atoms, would be arranged randomly, so they won't form crystals, so they're not a regular repeating pattern. So they lack an ordered internal structure. So this, think of rubber, glass, and plastic. So that is it for this section. So now you'll do your homework set 2. Thank you.